Now back propagation dense or fully connected layer, how it happens. Softmax neural network. If you have simple neural networks, it's something like that only. Like here previously we will be having CNN convolution layers, and then we have max pooling layer for suppose, then we will be having dense layer, and again combination of those in multiple times also will occur. For example, in some simple dense or fully connected layer, which is simple to simple artificial neural network or neural network, it will happen something like this. So inputs, then we'll get Z using W's and biases, weights and biases, and then we'll pass to softmax activation function, we'll get the output. Now to calculate that, we have binary cross entropy loss, and if you're using softmax, so yi will be this. Z is nothing but the, after passing input and multiplying with the weights and then adding bias, like something simply like this. It's not y, it's z plus bias, and then after passing through softmax activation function z, we will get y. So y is nothing but typical example of softmax. Equation is this, and these are all the classes, and z is this which I have showed, and now it is nothing but for all the weights, as you can show here, and j is for all the inputs also, because for each input we have also weights also in the combinations. So we need to find dy with respect to dz, because if you want to find derivative of loss with respect to weights, because again here we just need derivative of loss with respect to weights and with respect to bias, so that we can apply gradient descent like this, and we can get new weights using old minus learning rate alpha. This is again hyperparameter tuning for those things, how fast you need to go till global minima, how slow you want to go, how fast slow from both direction, that determines that using learning rate. Again from which direction, that's again using slope, which I just shown you previously. Now we need to find derivative of with respect to weight. For that we need to find derivative of loss with respect to z, and then z with respect to weights, and with respect to z, loss with respect to y. At first we will get from y only, because back forward propagation like this, backward propagation like this. So first we need to find derivative loss with respect to y, that we can find because y equation is over here itself, so we can just find derivative, and loss equation is over here itself, and we can just find dl by dyi hat. This is actual, this is predicted, and we can also, we have yi equation over here, so we can get dy by dzi also. So these two will be forming dl by dzl. If you find this, dzi by dw is nothing, it's simply like x only, because dz by dw we will get x only for that particular ith z, for that particular z or that particular term of x, because with respect to I or j we are doing. So this thing is nothing but softmax, that we have cases for I is equal to 1 and I is equal to L. That is nothing but if we have something like this, all this will be 0 or close to 0, and this will be 1, because only one output will be there. So this is that kth L, k is equal to L, so I is equal to L or I is equal to k. So this is that I is equal to L. If you have all the i's, that particular lth term which produces highest probability. So for that we will perform differentiation dy by dz, where I is equal to L, and here as you can see we are using UV method, u and v, and yes, we will get the formula will be something like this only, vu dash minus uv dash by v square, or else my reverse and give minus this one first, this one second, and give minus thing, and we will get the results something like this. Simplification you can do. This is here I want to show you one thing. This is u, right? So v will get first, v is over here, and u dash is that only will get, and minus u is this one, and v dash what happens is ezl, because for all the terms, other terms, this is sigma, right? For all other terms the value will be 0. For only I is equal to L, the value will be 1, and that value for that value only, like d by z, I is equal to L, for all the sigma k is equal to 1 to e z k, this will be 0 plus 0 plus 0 plus so on dz by I is equal to L. We will get zl value, and then again it will be 0 0 till k is equal to c, and for this term only we will be performing derivative. For other terms derivative is 0, and if for this term, for all terms we will perform derivative, but for other terms it will be 0, and for this term we will get e power zl itself, because derivative of e power x is e power x itself. If preceding to x we don't have any variable, like 2x means again 2 will come multiplied. So again if we will simplify, we will get this result. For I is equal to L, we will get this. And now for I is not equal to L, we will again perform like u by v only. We have v square this one, and as you can see v square is nothing but like this. This is nothing but this, and vice versa, and this is nothing but this, vice versa. And I is not equal to L, we will perform like this. E power z I will be there and multiplied by this thing. So u v vu dash and u v dash, and again we are getting this thing as 0 as we are differentiating with respect to zl. But in zi we don't have, no zl is there, right? So because it's not I is not equal to L, so other terms instead of L, so this will be 0 and this will be as it is, it will come. And what happens is like it's 0 means the whole thing is termed 0, and here again as I have said, in all will be 0 and only zl will come, as I have shown over here. That thing happens, like all derivative will be 0 until when k is equal to L, at that time it will be 1, and that is nothing but zl. So that will come over here. And as I have said, e power zi with respect to zl will be 0 because I is never is going to be zl. Here it was I is becoming zl, so that's why, because I is never is going to be zl over here, because I is never going to be L for zl. So with respect to zl we will not it will be derivative 0. Here it was because we are talking about I is equal to L case, so in that case it was e power zi itself, the term itself, so it's like 1. But here it will turn to be 0. 1, it's not 1 actually, it's term itself, because e power x derivative is e power x only, so 1 into e power x, something like that. But here it will be 0, and here, and from this you get e power zi, and this will be zl itself, because only that term exists in this expansion, because all the terms will be 0, because with respect to zl we are finding. And whenever in that sigma notation k is turned to be L, then it will be zl. With respect to zl it will be e power zl itself, because e power x derivative is e power x itself. And we will get this, and then this minus of this is nothing but this equation. So in y terms we can express, because y is this thing, and then yi into yl, zl, because that's why. And here also this whole thing can be yi and 1 minus yl, because z is there, I is equal to L.